All right, we're on to lesson 4.2, slope. I can find the slope of a line. This is a really long set of notes, so I am going to break this lesson into two different videos. So the first video is going to be the first part, and then once we get to parallel and perpendicular lines, I will start a new video. So look for 4.2 day 1 and then 4.2 day 2. But slope, let's start with the actual slope equation, or the slope-intercept form equation, which is y equals mx plus b. What we're focusing on today is this m value. That's what slope is. So slope is the ratio of change in y to the change in x. And we can find slope in a variety of ways. So the first way that we can consider slope is just looking at m and that being equal to the rise over the run. And we'll get into this a little bit more specifically in a minute. We can also look at slope as the definition says, the change in y divided by the change in x. And then the third way we can look at this is actually the slope formula, which would be y2 minus y1 over x2 minus x1. The slope formula, I don't want you to think that it's y squared. So y2, because it's subscript, because it's down near the bottom, is just saying it's a different y than y1 is. Same thing with x2 and x1. Just a couple things to know about slope is that if you are looking at it from left to right and it's going uphill, a lot of times I like to pretend like a person is climbing this hill. That would be a positive slope. And then as you look at it from left to right, if it's downhill, if someone's climbing down the hill, that would be a negative slope. And that's important to know because that kind of helps you check your answers when you actually find it. So let's take a look at a couple examples here. There's going to be a bunch of different ways to find slope, but the easiest way when you're given 2 points is just to use the slope formula. So the slope formula would be y2 minus y1 over x2 minus x1. And what I like to do is set this up like this first, and then it's easy for me just to take my y values, which would be 8 and negative 4, and plug those in, and I can do any order. I'm just going to choose to go 8 and negative 4, so remember the double negatives, that's going to turn that into a positive. And then because I went from 8 to negative 4, I have to keep that same order and go negative 3 to 5. So 8 minus negative 4 is 8 plus 4, which would be 12, and then negative 3 minus 5 is negative 8. And yes, we do need to simplify if we can. So 12 over negative 8, if I divide both by 2, turns into 6 over negative 4. If I divide by 2 again, turns into 3 over negative 2. A lot of times people's final answer is not going to have the negative sign in the denominator like you see here. So my final answer, I'm going to pull that negative sign out front and write it as negative 3/2. All right, let's do another one. Subtract the y's on top and the x's on bottom. Again, any order. I'm just going to start with the 10 minus 4. And then if I do that, I have to keep the same order on the bottom, which would be 1 minus negative 1. 10 minus 4 is 6, and 1 minus negative 1, so 1 plus 1 is 2. 6 divided by 2 simplifies to 3. So your answer there would be the slope is m equals 3. All right, let's take a look at how we're going to calculate slope when we're actually looking at a graph. And the first thing is you're going to want to find 2 points on the line. I like to call them pretty points. In other words, the points need to hit the graph perfectly. So if I trace this line over here on the left, I'll just kind of highlight this line in yellow. If I'm looking at that line, I'm looking for 2 points that actually are on that line that hit at good positions. So I can fill in a point here. And then if I trace that line down, I can see that another point is going to hit right there. From here, I think the easiest way to go about this, instead of doing the slope formula, so yes, the slope formula would work if you took points, but I think the best way to do it when you're given a graph is just to look at one of the points, and you're going to do what's called rise over run. Sometimes you'll hear me say, go from your house to Justin Bieber's house. But anyway, you'll understand that more when we go through it. But I'm taking this first point, and you can start with either point, and I'm going to do a rise. So I'm rising -2 because I went down, and then I'm running 3. And then that would be my slope. Something to consider is if you look at this slope, I could tell from the get-go that it was negative because it was downhill. And then if you look at my answer down here at the bottom, that's also negative. So that kind of matches up. So that means that I probably did it right. Looking at this over here, it's going to be a positive slope. It's uphill. And I already have 3 points on this line. I can choose any of the 3 to work with. I'm just going to start with this one right here. I'll darken this one in. And then I'm going to go to this one up here. So it doesn't matter where you start, but I need to do rise over run. So I rise 1, 2, 3. So rise of 3, and run 1, 2, 3, 4. So my slope there would be m equals 3/4. Now there's a couple special cases. There's horizontal lines and there's vertical lines. And the slope is can be done just a little bit differently. But I do want to just indicate that if we have a horizontal line, and we know this is a horizontal line because it says y equals, there's no other x involved. And what we learned in the last lesson, that anything that's y equals is going to be a horizontal line through whatever y equals. So in this case, it's y equals 5. I think the easiest way to memorize this, instead of trying to do some formula or try to calculate slope, not doing rise over run, a lot of times I just say if it's a horizontal line, your slope is going to be 0. Okay? And then likewise over here with x equals 5, if it's a vertical line, your slope is going to be what we call undefined. So it's the only slope that isn't a number. It's something, just a word that we need to memorize for that. And we'll get more into that, why it's undefined. It has to do with dividing by 0, which we are not allowed to do in math. On your calculator, you'll see it will say error when you do that. And then take a look at Mr. Slope Guy. You have positive slopes, negative slopes. That straight up and down, you can see the U for undefined, and then the horizontal slope is a 0 slope. So whoever came up with that, I thought did a pretty good job. It's pretty genius. All right, let's take a look at an example here before we get into parallel and perpendicular lines. So this example will end part 1 or day 1, but we want to use a table below. And this table shows the distance in miles of a space probe from a comet after it begins its approach. And we want to find and interpret the slope. So the first thing I want to do is find the slope. Again, there's many ways to do it. I don't have a graph, so I'm not going to do rise over run. I could actually do the slope formula, but with a table, there might even be an easier way, and we're looking for the change in y. So how do I go from 8 to 6 to 4 to 2? That's the change in y, and that would be -2 because I'm counting down, divided by the change in x. How do I go from 1 to 4 to 7 to 10? That would be +3. So if you do change in y over change of x, that's another way to find slope. And so my slope in this problem would be -2/3. Step 2 says I should reduce it. Obviously, this fraction can't be reduced, so I don't have to take care of step 2 here. And then step 3, interpret the slope. So basically what that's saying is, what does this slope mean? And if I go back to the word problem above, it's talking about the distance in miles from a space probe from a comet, which is minutes. So it's basically the y value, which is my top, the numerator, is a distance in miles, and then the denominator is a time in minutes. So if I'm interpreting this, I would say that for every 2 miles, and it's negative 2 because it's getting closer to the probe. For every 2 miles, it takes 3 minutes. So it's basically just looking at the situation and describing what the y value on top means and what the x value on bottom means. That'll conclude part 1 of this, day 1. I will have another video starting with parallel and perpendicular lines for day 2. But this is a long lesson, and